All right, I'm just going to do a quick sort of mental wireframing of this experiment. Pardon any background noise. I'm at home and don't have a good recording setup today, at least. The standard model is that the Earth is spinning at, let's just say, relatively supersonic speeds. The equator about 1,040 miles per hour. And I'm not going to get into sort of absolute speed versus revolutions per minute right now. That's a different topic, but taking that as a given for the purposes of this thought experiment, which hopefully will become a physical experiment, I will say that we're spinning at hundreds of miles per hour, over 1,000 miles per hour at the equator. That's one. So given number one. Given number two is that we are going to presuppose and accept the standard model that the atmosphere is spinning in lockstep, or velcroed to the surface of the Earth, and we'll just look at the area close to sea level. We won't worry about the challenges, perhaps, or side questions about how that would manifest further from the surface of the sphere, in terms of the uppermost atmosphere spinning much faster, or significantly faster than the speed at the closer to the ground. Two givens then. Earth is spinning at x speed, and the atmosphere is spinning at the same speed. Fine. So with that, I want to try and model using some fluid dynamics. Just scale down in maybe like a clear bowl with clear Lego to emulate structures, buildings, houses, things like this, and then maybe some dye and clear water. Record this. And the dye will be injected inside the Lego edifice once I start a spinning of the water inside the bowl. With that Lego structure, scale down structure, of course, inside the bowl. I'd like to see what the behavior is of the colored fluid, the dye, inside the structure. Because what I'm thinking is that if the atmosphere is spinning at, let's just say 700 miles an hour, if we're kind of northerly in our latitude, so 700 miles an hour, that's fine. Let's accept, we'll accept for now that it would not be noticeable to us because we are on a surface that's also spinning at the same speed. Fine. If that's happening when you're outside, what happens when you cross the threshold into, like a door, right, into a building or your house? Is the air that's inside spinning at the same rate? What happens when you close that door? And what happens when you go past the first sort of layers of doors and you go into an elevator, or you go from your living room and then into your bathroom, close the door? It's just logically, we're not expecting, of course, that the differentials, if there was spinning air in the atmosphere, spinning at that rate, we're not expecting that would persist inside your house. And if it was persisting, and if it could be argued that it is persisting in some way, how would that manifest? So just do a little further wireframing, perhaps, and then build out a little experiment. The atmosphere can be represented in terms of a fluid. So I think that experiment will basically work. Start it spinning, use a sort of turkey baster dropper syringe to inject food coloring into the top of what would be, or some portion of that Lego structure. It just has a little opening that would simulate a door or sunroof, something like this, and see how that manifests inside a structure. Because I think that it'll demonstrate very clearly that one part of this, at least, that if we were spinning and the atmosphere is in lockstep, the dynamic that you see out in the open, as it were, would not be the same as what you would see indoors. And the differential would be tremendous. And very much noticeable, like far past the threshold of any kind of need for a sophisticated measuring device. We'd be blown away. as soon as you try and cross out or in to your own home. All right. Thanks all. Or nobody, whoever watched this. Thanks.